Welcome to the Unit 2, Section 5 video on applications of functions. Recall that functions have dependent and independent variables. Dependent variables are your y values. Independent variables are your x values. The dependent variable will always depend on the independent variable, okay? And that makes sense, right? Because our independent variables are our inputs. And whatever our input is, controls what our output is going to be, and that's our dependent variable. So it depends on what you put in for x as to what you're going to get for y. The independent variable represents the x-axis, or the input. The dependent variable represents the y-axis, or the output. The dependent variable is a function of the independent variable. Because again, your independent variable goes in, your dependent variable comes out. So let's talk about our notation here. Y is a function of x, y being our dependent variable. Y equals f of x, where equals takes the place of is a function of, okay, is. What is equals, a function of x is f of x. So identify the independent and dependent variables in each situation. In the winter, more electricity is used when the temperature goes down, and less is used when the temperature rises. The amount of electricity used depends on the temperature. Okay? So, if the amount of electricity used depends on the temperature, our dependent variable is the amount of electricity because it depends on the other item, which is our temperature, being our independent variable. A lot of times our independent variable is something that we don't have control over. We don't have control over what the temperature is outside. Another common thing that we don't have control over is time. You can't control time. So oftentimes time is going to go on your x-axis because it is an independent variable. The cost of shipping a package is based on its weight. So the cost of shipping a package depends on its weight, okay? So since the cost of shipping a package is dependent on the weight, the cost of shipping a package, or the cost, is your dependent variable, and the weight is our independent variable. The faster Ron walks, the quicker he gets home. So how fast he gets home depends on how fast he walks. The time it takes Ron to get home depends on the speed he walks. So our independent variable would be our speed. Our dependent variable is time. The time it takes is dependent on the speed he goes. So this is one of those cases where the time is dependent on our speed, which is our independent variable. But oftentimes, time is going to be independent, especially when we're just talking about time in general. Now that we can determine what our dependent and independent variables are, we can start to write functions. After identifying which variable is which, we can write a rule in function notation. Remember that f of x is the dependent variable and x is the independent variable. Suppose Tasha babysits and charges $5 per hour. The time worked is going to be our x, or our independent variable, and the amount that she earned is going to be our y, or our dependent variable, okay? Because the amount that she earns depends on how much time she works. So if she charges $5 per hour, if she works 1 hour, she will earn $5. If she works 2 hours, she's going to earn $10. If she works 3 hours, she'll get 15, and if she works 4 hours, she'll earn 20. The amount of money Tasha earns is $5 times the number of hours she works. We can write an equation using two different variables to show this relationship. The amount earned is $5 times the number of hours worked. So the amount earned is our y. You can see that in our table. That's our dependent variable. Is another way of saying equals. $5 is just our 5, times is multiplication, and the number of hours worked is our independent variable. It's our x. So we're going to put x in place of that. So we get y equals 5x. We can find out how much she earned by putting in how many hours she worked. Since y equals f of x, Tasha's earnings, y equals 5x, can be rewritten in function notation by putting f of x in for y. So f of x equals 5x. If Tasha wanted to know how much money she would earn by working 6 hours, she could input 6 for x and find the output. So let's identify the independent and dependent variables, and let's write a function for each scenario. A lawyer's fee is $200 per hour for her services. Our dependent variable is the price. The independent variable is time, because the price that we pay is dependent on how much time we use. So we can write a function for that. F of x, our price, is equal to 200x, 200 times the number of hours that we use. Stephen buys lettuce that costs $1.69 per pound. The price is dependent on how many pounds, or the weight of lettuce. So f of x, our price, is equal to $1.69 times the amount of weight of the lettuce. An amusement park charges $6 parking fee plus $29.99 per person. So our price is dependent on the number of people that go. Our function is $29.99 times the number of people that go plus our $6 parking fee. That will give us our total price, which is our dependent variable. Now, when we're looking at the solutions to problems, what our outputs are versus what our inputs are, it's important to keep in mind if the inputs and outputs that we are getting are reasonable. Just like when we're solving a problem, a real-world problem, is it reasonable? Or should it be some other value? It's a good way to check yourself. So when a function describes a real-world situation, every real number is not always reasonable for the domain and range. For example, a number representing the length of an object cannot be negative, because you can't have a negative number of inches. You can't have a negative number of miles. And only whole numbers can represent a number of people. We've talked about this. You can't have a fraction of a person. So when finding reasonable domain and range, you need to determine what inputs make sense for the problem, and then plug the inputs into the function to find the outputs. So in this example, Manuel has already sold $20 worth of tickets to the school play. He has 4 tickets left to sell at $2.50 per ticket. We want to identify the independent and dependent variables, write a function to describe how much money Manuel can collect from selling tickets, then find the reasonable domain and range for the function. So the amount of money collected is dependent on the additional tickets sold. So those are our dependent and independent variables. Our function is going to be $20 that he's already sold plus the price per ticket times how many more he could possibly sell. So that's 250x plus the 20 that he's already sold. So our domain is 0, 1, 2, 3, and 4 because he has 4 more tickets left to sell. He could sell no more tickets. He could sell 1, he could sell 2, he could sell 3, or he could sell all 4. If you plug in all 5 of these numbers into the function, these are the possible outputs that you would get for the range. So he could end up selling $20 worth of tickets if he sells no more tickets, all the way up to $30 worth of tickets if he sells the 4 that he has left. A construction company uses beams that are 2, 3, or 4 meters long. The measure of each beam must be converted to centimeters. We want to identify the independent and dependent variables, write a function to describe the situation, and then find the reasonable domain and range for the function. So the beam length in centimeters is dependent on the beam length in meters. So to find the length of a beam in centimeters, if we know what they are in meters, we know that to get 1 meter into centimeters, 1 meter is 100 centimeters. So we multiply that 1 meter by 100 centimeters. That's our conversion factor. So our function is going to be our length in centimeters is equal to 100 times our length in meters. So we have beams that are 2, 3, and 4 meters long. So we put 2, 3, and 4 into our function, and we get our output of our beams being 200, 300, and 400 centimeters long. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.